Welcome to our next video. Today we'll be designing the sheet metal structure of our lamp project, and you can see that we already have the lamp mill part open, and that model is provided, and we have the lamp lathe part open, and that model is provided, and we have the lamp shade that we've recently designed. And if you haven't designed yours quite yet, that's okay. You can still get started on the structure and then add the shade in later once you have it. So with a brand new part file, let's go ahead and start designing the structure of our lamp. So I'd like to just start with a sketch on the front XY plane, and I think what I'll do is base my lamp link arms off of the design from a slot going center to center. Now, you're certainly free to design the structure of your lamp in any way possible using any of these geometry features. We are going to be laser cutting it from thin steel or aluminum, and so long as you stick with a two-dimensional flat design, anything you can draw, we can cut it. But I'd like to keep this very simple for my project, and you can certainly bring in quite a bit more creativity to your project. So I'm just going to get the basic shape down of the link arm, which is this slot feature, and I'll go ahead and bring in a couple of circles to each end of the slot, and I'll draw them a little bit different sizes, but I know in the end they're going to be equal, so I'll apply an equals sketch constraint to these, and I'll go ahead and give them a dimension of 0.27. I think that'll work well as a clearance for a 1/4 bolt, which has a major diameter of just under a 1/4 inch, 0.25, so 0.27 should clear that nicely. Now, for the size of the link arm, how big should we go? Let's keep it reasonable. I'm looking here at a ruler in front of me on my desk. I think we'll start out with about 4 or 5 inches or so, and we'll see how it goes from there. I'm thinking maybe a couple of 4-inch link arms will ultimately give our lamp a height of somewhere around 8 inches or so, which should be good for the size of LED module we're using. So there's 4 inches center to center, so overall the link arm is coming out a bit longer than that, and we can go ahead and give it a width here. And again, looking at the ruler or caliper in front of me, I think a good size for the style I'm going for with my lamp is going to be somewhere in the neighborhood of maybe 1 inch or 1 1/4 inch. I think I will try 1 inch. And we'll see how that turns out. Now, already I'm getting a little concerned that these ends are bigger than what may fit up with the mill part and my 3D printed lamp shade. I'm not sure that I've left enough space to have that big of a radius down toward the end. So already I'm starting to rethink this design. I might go for a narrower slot shape, or alternatively I might go for a little bit of a different design altogether, which is what I'm thinking at the moment. So let me go ahead and delete the slot features. So really the essence of what I've started with is 2 holes, each of diameter 0.27, and they're located about 4 inches apart, which looks good for our size and scale of design. So next, I'd like to bring in a couple more circles at those same centers to give me my outer profile. So I just made those equal, and I'd like to keep those in the neighborhood of maybe 0.5 or 5/8, 0.625. I think I'd like to try that. And I'm getting some ideas about the style of my design. I'm thinking that I'll use lines, and I'm going to snap this line to the circle, but I'd like to not snap it right to this side point here. I'd like to place it at more of an arbitrary location on the circle so that I can use constraints later to bring it in the way I'd like. In fact, I'll do that up here, and you can see it's chopping through the circle a little bit. Let me use a little bit of a different technique down here. For this one, I'm going to drop that line just out in space, trying not to snap it to anything whatsoever. And I'll go ahead and do the same things over here. In fact, I think it might be simpler for me to just drop them out in space like this. And I'm going to come back with some tangent constraints. Tangent is just a nice way to make everything smooth and aligned. A lot of engineered and well-designed products have tangent lines and curves. That one looks like it went in nicely. You do have to check sometimes to make sure that you're not cutting across the circle with a chord as a segment of your line. I'll go ahead and make this one tangent, and notice I drew my lines a little bit longer than the circle, so I'll have to come back and trim them later, which is not a problem. And we're making everything nice and tangent here, and that looks good. So we'll come in with the trim tool, which is keyboard shortcut X, and we'll just trim all these right to length. So I'm getting an idea for this sort of diamond-shaped link arm that's maybe narrower out here toward the ends, 5/8, and perhaps wider in the middle, so it's a beam. And I haven't decided really if I'd like to do something sort of abstract like this, or if I'd like to kick it back in like this, almost in more of a boomerang shape. And it looks like I might have snapped to a construction line there by accident, so I'll Control-Z a couple times on that. So I'm just taking that point and I'm seeing what I like. It's really my choice of what design style I use to connect those two link points. We literally can put just about anything in between. I'm thinking I'd like to keep sort of a narrow diamond shape for my design, and I snapped these right down to horizontal with the midpoint of that construction line. And that construction line is an artifact that's left over from when I drew the slot, but you could certainly draw a similar such line on your own, joining your two circles together. It should be noted that mouse snaps are actually not a hard snap. I can still move that later. So what you may want to do is come up here and use a horizontal constraint to get that center point aligned with your midpoint. And if you're on the top sketch plane, that would probably be a vertical constraint. Next, I think I'd like to make all these equal length. Symmetry is a nice thing sometimes. So we'll go ahead and do that. And I think these might already be, by definition, yes. Adding this constraint will over-constrain the sketch. So it shows me in the lower right that one dimension is needed, and we can sort of pick and pull things apart and see what dimension that is, and it's just this way. So I think I'll go ahead and put a dimension that way for myself of, oh, now I can go, let's call it, I'm going to look again to my caliper or ruler here. Let's call it, in my design, I think I will stick with that 1 1/4 inches that I was going for in the first place. So that gives me some nice scale here. And I can go ahead and just extrude out this shape as is. It is 3 regions, so I'll have to pick it. Now, the thickness of your extrusion in CAD technically doesn't really affect how your part turns out in the laser cutting process, but we want to have our CAD model match the actual material we're going to be cutting. We do have 0.060 thickness steel, but chances are we'll do these link arm parts out of 1/16 aluminum, which is 0.0625. It's completely reasonable to round that to 0.063, or really even 0.06 if you wanted. This application is not too specific. However, if we were doing bent sheet metal, we would need that perfect and consistent throughout. But I'll go ahead with 0.063 as a very close representation of 1/16 of an inch, the actual thickness of the aluminum that I intend to use for this project. So I have the essential structure of my link arm modeled in just under 10 minutes, and it has a little bit of artistic style, but we are putting this into quite an advanced laser cutter, so we might as well add a bit more style to it. So I'm going to start a new sketch right on top of my solid shape, and it is important to not do too much in one sketch. I'll go ahead and project all the geometry I have, and if you haven't set those options in your application yet, go ahead up to your File menu and choose Options, and there's a couple of defaults that I'm not crazy about under this Sketch tab. By default, Auto Project Edges during curve creation is turned on, and I really don't like that. And there's another option called Auto Project Edges for sketch creation and edit. That one's okay, but I tend to leave them both off so that I can choose which edges I want to project or include. The one I do leave on is Auto Project Part Origin on Sketch Create. I do leave it on just like this. So we projected our edges from our shape. Now I think I'd like to potentially try using the Offset tool to keep a thin web around the outside. And I see I have that here. So it's giving me a choice of how far in I bring that offset, because I'd like a shape that is something like this. So I'm going to offset mine maybe 1/4 inch and see how that looks. And it's all locked down because it just is offset. Now if I straight went to extrude this, I'd have a little bit of a problem in that it goes all the way through to the holes, and I need to keep some material there for the pivot points on my link arms. So I'm going to undo that and back that up a minute. And I think what I'd like to do is bring in some more circles, perhaps even similarly to what I had before, right up to my part. That looks pretty good there. So I can do a bit of trimming with the geometry. I'm not sure why this one is still green. It looks like it didn't do a hard snap for me. So I can go ahead with an equals and say the radius of this circle needs to equal the radius of this arc. Now everything is fully constrained, which we really like to see in good, proper sketches. So I could come back and extrude this region out, but it still looks like it's not picking. And if I hold my mouse long enough, sometimes I'll get a select other option, but it looks like right now this is my only option. So I may need to come in with the trim tool and take out some of these areas here. And we have to be careful not to move our geometry past this point, because you saw it went from black to green when I trimmed it, so it's no longer well constrained and it can move around on you. So I'm trimming these lines. Sometimes Inventor doesn't really like extruding certain regions if the lines extend and cross others. So let's try it from here, and it looks like I can get that region through the part with no trouble. Now this looks okay. I think I would like the style of this design, and the laser is capable of cutting these sharp corners, unlike a router or something of that sort. But in engineering design, sharp corners do lead to stress concentrations, stress risers. So I'd like to come in and put some fillets in those corners, and I might even experiment with adding a little bit more style to the design of this part. So I'm going to do that back in the same sketch, actually. And you know, I might even Control Z back to where that was just an offset shape that was not trimmed, and I do have the circles in there. And I think I might like to try doing some sort of pattern like a truss, like this, which I think looks kind of cool in the design. So I need to see how we might do that. I can potentially try drawing a construction line, which is not going to be a hard solid line. It's just to help lay things out, and it's really subtle in this color mode, and I'll see if this zoom in gets captured on the video. It's a little dashed line there, and they're showing up yellow in the Millennium color scheme, and I'll go ahead and draw a few more in. And I do want there to be some sort of regularity to it. So I'm thinking the two in the middle should be equal length, and I'm thinking the two on the ends should also be equal length to each other, but not necessarily to the middle. In terms of angles, we can use a general dimension and just go from one of our geometry lines to the construction line, and I can put an angle in there. So let's call that, something similar to what I'm seeing, maybe 135 degrees. And I'm going to try to do a similar angle over here on this line, and I might bring the angle just out this way and do the supplement of it, 180 minus 135, so we get 45 degrees. But that's off of a different line. For some reason that doesn't look quite like I intended, so I'm going to Control Z that. That 35 there is closer to what I was looking for. So we have to keep in mind which line we are referencing. Let's just, for the sake of it, look at this dimension here. Yeah, that's about 145. So I'm curious if that were 135. That just brings that a little tighter than I wanted to see. I'm wondering what would happen if we opened up this angle right here. And it looks like that got locked into a hard 90, which is not my favorite thing, but we might be able to go with that. I was trying to see if we could move that point there. And what's very peculiar is already we are fully constrained. So I'm wondering if maybe by definition of the lengths of the lines, this truly is fully constrained with how we made those equal length. So if you are fully constrained, nothing else can move, and something has to give. Either an angle has to go away, or one of those equal constraints that we see here, that was F8 on the keyboard, has to go away, and that's F9 to hide them. So I need to rethink this a little bit in terms of how I draw it. I might just freehand it for a moment. Curious what happens if we snap that construction line there. So that becomes fully constrained. And these, super interesting. Yeah, just by definition, by length. So we had, I'll trace over, we have this construction line in red and this construction line in green defined as equal lengths. And then each of these in orange we had as equal lengths as well. So this actually ends up in a perfect symmetrical about this yellow line position, which I kind of like, and I think I might go with that. So my construction lines are nice and locked in. Now I'd like to get some real geometry lines, so I'll turn off that construction, and I think the way I might do it is with an offset tool. And I'll offset from those construction lines over a distance, let's see, I'm thinking I might try to keep that 1/4 inch web thickness as sort of a theme throughout this part, but as I look at it, I realize that the open areas in the part might be getting a little small. So before I do that, I'm going to change my 1/4 inch web to maybe simply 0.2, and that opens up the part just a little bit. Now I'm going to offset from my construction lines by 0.1. And you notice they extend a little longer, and that's okay. We can fix that. And I'll offset this way by 0.1. And you'll notice these cross here, and that doesn't quite reach. All of this is fixable in a moment. So let's just continue offsetting. And I forgot the dimension on that one. We can drop that in with the D, General Dimension tool, 0.1. And we can drop our next offset line in and give it a 0.1 as well. So this is looking like a pretty cool shape, and I'm happy with it. We do need to make these lines reach to the end, so I'm going to use the Extend tool to do that. And you pick the line you want to extend, and more often than not, it'll take it right where you wanted to go. So let's see, do we have any others we need to extend? Just one down here. You see the little highlight preview in green, and we're looking pretty good at that point. Now we're no longer fully constrained, and we could certainly do some dimension work and get ourselves back to fully constrained. And if this were a production part for a real engineering firm for a customer, we likely would make sure our sketches are fully constrained. But for a student artistic project, it really seems to be okay, and more trouble than it's worth to go constrain all of it. So do know the difference. Proper practice is everything fully constrained in sketches. You don't want it moving on you like this. So we could certainly put that dimension back in, but we're going to go break quite a number more constraints here momentarily with the trim tool. So let's go ahead and do that, and we'll take this line out, and we just want to get everything back real clean to where this will be a clean extrudable region, really. So we're taking these out. So you have to kind of think of your design in terms of positive, negative space, what stays and what goes away. Now, some of you might be tempted to add fillets at this point in your sketch, and I would strongly recommend against that. It's much preferred to do fillets in the 3D space than in the 2D sketch environment. So this looks pretty reasonable at the moment. I'm not confident that these green lines haven't moved, but we could certainly check it with a measure tool, and indeed they're 0.2 inches apart like we intended. So this looks pretty good. Let's see if we can extrude out. Nope, we still have that issue with that region leaking into the center where our pivot hole is. So let's do a couple more trims right up there, and now we see the whole sketch has gone green. So this would be quite a bit of work to bring this all back into fully constrained. So it's one of those things of draw your geometry with the constraints, get it in the right place, make sure it is, and after you start trimming, you're pretty much done at that point. Done in terms of being able to make future edits. It becomes quite difficult without breaking the whole sketch or without adding a lot of constraints back in. So these look like the right regions. Let's see if they can extrude. Indeed they can. Let's cut them through all, and that's looking pretty good. So again, in a real engineered design, we would do some finite element analysis on this or something to optimize the position of the truss members. But for our design, we know it'll be plenty strong with the light loads on it, and we're mainly going for the aesthetic here. So at this point, let's go have some fun putting in our 3D fillets. And let's just start with that 125 radius, and I'll get the most narrow one and see how far it brings it out. And you'll see that really filled that region quite a bit, and I'm losing a substantial amount of the open areas in the model. So let's see if we can bring that radius back down to a little bit more reasonable number, a little bit of a smaller radius, so maybe 50 thou. And that gives us a nice radius, but still keeps the look and appearance of our design. So I think I'll just start putting these in. And you do want to be careful about your mouse clicks. And if you hit one by mistake that you didn't mean to do, you can just hold the Control key and click that edge again. Control click is a deselect. So just orbiting around, holding F4 on the keyboard and zooming in and out with your scroll wheel, and it'll zoom where you point it. So you bring your mouse to that corner and zoom right in there, hold F4 and orbit around. You can get really good and fast at this with some practice. So we're getting all our fillets in there. It's looking pretty good. And you can even pick them through the backside like this, even if you can't see them directly. And that does work just fine. I like giving myself a good view angle where I can pick them without accidentally selecting a different edge. And let's get this region up here. And then you want to look at your number of fillets and say, okay, does that make sense for what I'm doing? You know, if you got some number like 19, for instance, or 17, it might raise suspicion that you might have missed one. So you do want to look over your model and see, depending on your shape, you know, it could be an odd or even number, but look that it makes sense to you and that you didn't miss one, because it's very easy to do. And we'll say apply, and that looks really great, actually. The only last thing I'd like to do is put a little fillet right over these two surfaces, and I'm doing that as a separate feature because I might want it to be a different radius than what I used on the inside. You can see that's pretty small there. Just for example, let's see what a 0.5 would look like, and you know, I may even stick with that. I do like the appearance of that. So we have a nice truss beam here. for the link arm for our lamp, and I'm going to go ahead and celebrate with a save and call this link arm, and I'll give it a V1 just in case I come back and revise this at any point in the future. So let's go ahead and tile our windows down here. So again, we have our mill part, our lathe part, our shade, and yours might not exist yet, but that's okay. And I've got my link arm. The next thing I need to do is design the base of the lamp. So let's do a brand new part. Everything that's an individual part in real life does need to be an individual part in CAD. That's just a good modeling workflow. So we'll start a new sketch, and for orientation's sake, I'll go on the top plane, which looks to be the XZ, and it does rotate it 90, which is a little goofy to me, but we'll go with that. We can do a lot with our shape of the base, and we can put some customization in there. I would say a center point rectangle is really a basis. You could do some sort of wavy shape like this, maybe something that is shaped like a gear or a cam or something of the sort. You could bring a little style into it by curving some part of it. In fact, as I look at that, I think that might be neat actually if I brought in a curve and it was shaped sort of like this. I think I might give that a try on my project. But we can start with a rectangle, and I'm thinking a size of 4 inches ought to be adequate. And I would like mine to be basically square. Yours doesn't have to be, but since I'm going that way with mine, rather than putting a separate dimension over here, I'm just going to use an equal constraint from my sketch constraints and make that right into a square. I'll go ahead and extrude it out a distance of 0.06 or 0.063. I haven't decided yet if I'll be going with steel for the base or aluminum, but nonetheless the DXF we export has no thickness, so either way should be fine in your model. You just want it to be reasonably accurate. So let me try to do that sort of cutout shape by starting another sketch, and we'll project this geometry so I have it, and you see that as the dark purple or medium purple lines here in the Millennium color scheme. And I'm thinking I want to use maybe an arc to do it. So let's see if I were to anchor this here and here, and I was hoping for something more like a parabola. But a parabola is not a constant radius, so the arc tool won't do it, actually. That won't be suitable. There could potentially be a way to do it with a couple different radius arcs that are tangent to do some approximation. Splines I wouldn't recommend. At some point in the process, I believe they get converted to lines and arcs when we go to laser cut. So I might rethink this and just go with lines for a bit of a harder edge shape to my design, something like this. And what I'm looking at is this line really can be anywhere, and I need to control that. So I'm going to use one of these constraints, either horizontal or vertical, to get the center point of that line aligned with my sketch origin about which my square was created. So in this sketch orientation, the top is rotated, so it's actually vertical ends up horizontal as we look at it on the screen, and that looks pretty good. The next thing I'd like to do is make sure these lines are equal length. Symmetry is a nice thing. And now we need to put some dimensions to it. So from this front edge, I'm going to come back, let's say 2.5 inches, and I'd like this line to be maybe 1.5 inches wide. Let's see what would happen if we took that back. No, I think I'll stick with that. I do like how that looks. So I'm pretty happy with this. Let's see if we can extrude cut it out. That looks pretty good. So I can do some more. I can put some fillets in it, or on it. Whoops, not the whole feature. Fillets is what we were going for there. And we can certainly pick them. The sheet metal cut to a sharp corner is going to end up pretty sharp. So you do want to fillet your edges to some degree. Okay, and I like what I see. So something like this is going to be the base and structure of, the base for the structure, rather, of my lamp. Now, I want to measure the front part here. Whoops, M for measure. 228. I do have some little rubber feet we're going to put on there. And I'm thinking that maybe should be a little bit wider so I can get those rubber feet all the way out toward the front. That's hardly a 1/4 inch wide. So let me go back to my sketch. And in fact, we are not quite defined on that yet. So let me put in one more dimension from the side to this line here of, let's try 0.5. And with our fillets, that should leave us a good 282 in that region, which I think is just fine. So I kind of like the design. It's looking pretty good. I'm going to go ahead and celebrate with a save, and I'll call that my lamp base V1. Okay, we're almost ready to build the bulk of our lamp here. So we now have our lathe part, our mill part, our link arm, and we'll have several copies of that. And then our base and our shade, perhaps, if you've modeled it already. If not, that's okay. So at this point, I feel like we're ready to make an assembly. So I'll make a new assembly. And to place the parts, I like to just tile the windows and bring each one in there. So we'll start with the base, and we'll just drag it from the browser, and that's now in our assembly. We'll get our mill part, and we'll drag that in. We'll get our lathe part. We'll drag that in. And we'll get our link arm, and I can put a few of those later. And I'll get my shade. I don't need it yet, but we'll need it eventually. So I got all my parts placed in, and I'll come back to my assembly. Alternatively, you can use the place tool, but you'll have to browse for it. The first thing I want to do is get some of these out of the way. But then I really want to join the mill part to the base. So I'm thinking that I need to ground the base, which it already is, as indicated by this little push pin icon. And then I need to use a constraint to select the top of the base, and I'll orbit around and select the bottom of the mill part, and I'll say apply. The next thing I need to do is get the orientation right. And I need to get them kind of lined up. I want this thing spun around this way and sort of centered toward the back of the base of my lamp. So I think what I'll do is actually mate this flush with the back edge. Now, if you don't have a straight edge on the base of your lamp, you'll need to do something different with where you constrain it to, and I will leave it up to you to make that work. One technique is you could have potentially, let's move this out of the way temporarily. Oh, that's not moving for us. Let's move this one. You could model the couple of holes in your base plate that are a match to the mill part, and I believe that's 0.7 on centers. Yes. So if you did that, then you could constrain right to the holes. I didn't know exactly where to put the holes when I was designing the base, so I'm going to get the mill part all constrained in and then model the holes adaptively. So we want this centered. The best easy way to do that is with a work plane. So I'm going to open the mill part. In fact, it's already open, but that'll just bring us back to the right tab. And I'm going to give myself a mid-plane between two planes. From here, orbit around to here. Now we have that nice work plane right in the middle. Now on my base plate, I'm going to maybe do the same thing. Let's see. I have these sides as purely rectangular, which is okay. I'm not sure if I want to keep it that way or not. I'm looking at the style of this, and I can't help but thinking that this would look pretty cool if it came back about like that. So I'm thinking I'm going to make that change now on my model. I'm noticing these fillets are no longer going to be needed. I'll just go right ahead and edit and get rid of them. Not a crucial step, but that's just part of a person's style in modeling and being particular about things like that. So let's start a new sketch up on here, and I'd like to project everything I already have, and I'll go ahead and make a line out to here, and I'll do the same over on this side. It is a symmetrical part. We could have drawn half of it and mirrored it, but I like to visualize the whole thing at once. Let's use a parallel constraint from here to here, and they don't have to be parallel. Again, that's just a design choice I am making, and for the sake of symmetry, let's make them equal. That looks good. And I think we only need one dimension remaining now, which could be from really anywhere to one of the endpoints of this line. And I'm thinking 0.7 looks about like what I'd like, and I'll cut these corners out. Okay, I kind of like this shape. I need to go ahead and throw some fillets back on there. I don't recall what radius I used before. Looks like 0.125, and I think I'll stay consistent about that. And I have 4 of them to go get. That's 3, and I'll pick this one from the back side. There's 4. So we have our fillets, and we can come back to our assembly and see that everything's updated. It's always a good idea to hit that lightning bolt icon if you've made changes. So we were getting this positioned this way, and we need a work plane on our lamp base. So back to the base, let's make a plane as a mid plane between 2 planes. And these are actually still parallel, so I can go between there and there. So I've got a nice mid-plane, and what that allows me to do in my assembly is simply constrain the 2 planes together. Work planes in Inventor have a yellow side and orange side, so it looks like these planes are going opposite directions, yellow and orange, so they should constrain right together for me, and they do. If that doesn't work out for you, you might need to try the flush solution on your constraint. So that looks great. Everything's lined up. We need to get those mounting holes in. So now I'm going to save the base and close it, and we'll do in-context editing. We're going to be editing the base plate from within the assembly, either by double-clicking or by right-clicking and saying Edit. And you can only edit a part in one place, so if you're doing it in the assembly, you only get that option when your part is closed and not open on one of the tabs down at the bottom of your window. So we're editing the part. It's white in our browser. The other things are grayed out and kind of ghosted out in the background here. We'll go ahead and sketch on it, and I'll orbit around a little bit. And I'm going to project geometry, and we can kind of hunt and hover with the mouse and see if it picks it up, and it looks like we're getting it there. Is that the one? Let's try it. It indeed looks like that's the one. But I'm wondering what happened to my constraint here. My work planes are no longer aligned. So a slip of the keyboard may have caused that to undo, but that's okay, because now that this geometry is adaptive, as indicated by these red and teal circular arrows, when we go to update those work planes, those holes will move with us because we've projected the geometry from one part onto the other part in our assembly, creating those adaptive links or adaptive references. Let's finish that sketch. Let's return to our assembly. Indeed, the work planes are off. This is still, I believe it to be free moving, but because of that adaptive link, it no longer will drag freely. So let's try to put that constraint back in between our work planes and apply it. And it moved into place, and the holes went with it, and they're perfectly in the right place. So I'll get back into editing the base plate once more with a double click. We'll say E. Oh, not quite yet. What's the diameter of these holes? Only 0.196. Not enough for our 1/4-inch bolt to fit through. Let's get our sketch circle, and I think we need to get actually back into that sketch. Double click, we're editing the sketch, we're making a circle, we're bringing it out larger. Alternatively, you could use the hole tool, but for just a couple of them, a lot of times I like to draw the circle in the sketch and extrude it. We know these will be equal size, and let's put a dimension of 0.27. Looks good. That's a clearance for our 1/4 inch bolt. Make sure you take the whole thing when you extrude it, and we'll cut it through all, and that only relates to this part. So we'll say OK and return, and we can see that the holes in our base plate are perfectly aligned with our mill part. Now from this point, it's just putting our lamp together. So let's go to town, constraining our link arm. I'm going to go axis to axis. Looks good. And let's escape and bring it out. I need 3 more link arms. Control C, Control V, 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 holding the Control key so I have them all. Let's get our shade out of our way. Let's constrain the next link arm, axis, and you pick it from the inside of the cylinder, and you see that dashed line to indicate axis. You come around, and we'll get the axis of that hole and apply it. Might as well get the 2 tops of these while I'm in here, axis to axis, and apply. And that's looking good. We need to keep them from sliding apart, so let's constrain the face of the mill block to the interface of our link arm. And apply. I was just looking to make sure I had the link arm flipped around the right way. If we didn't, let's see what would happen. If we were this way, our features would not align. And maybe you want that for style, but in my style I want them to align. So there we have it. Let's constrain the face. Oops, we're picking all these work planes. We can maybe turn them off so they're not visible. That one's in the mill part. Okay, and let's constrain the face of the block to the face of the link arm and apply. So that's looking really good. Let's bring in our next 2 link arms. We'll go axis of the hole to axis of the hole, and while I'm up here, let me go ahead and get axis of this guy to axis of this guy and apply and escape, and it's looking pretty good. Making sure things are lined up, and we'll get these axis to axis. Whoops, I think I picked a center point there. It'll work, but that really is only a point constraint. In real life, if it's axis to axis, it's good practice to go with an axis mate. Apply. You might get some degrees of freedom in your model that you didn't want if you don't go by axis. So speaking of that, these are still moving in and out. Let's get them right up against these inner link arms. Apply, face to face, and apply. This is looking really good at this point, and you might get some goofiness in which way it wants to go, and that's fine. It's free in Inventor right now. Now I do want to bring your attention out to one area, and that's the space between these link arms. If we press M on our keyboard and measure in there, we're going to get 1.32, and I'm a little high here, 1.326, because I went 0.063 on my material thickness. In our other video on designing the lampshade, we told everybody to be sure to go 1.32 on the width of the mounting feature on the lampshade. So you'll see that's a match. If we're a few thou off, in this case everything is flexible enough, we're in tolerance, it's going to work out. But you do want to keep that pretty close to the same. Let's go ahead and constrain our lathe part in. Let's get the axis from the outside. If you have a modeled thread feature, it's possible to pick up a different axis. These are cosmetic threads from the hole feature, but still good practice. Grab it from the outside. The hole on the inside is coaxial. And let's just take it to the axis of this one, and we'll take the face of the end of the lathe part right around to the interface of our link arm and apply it. So this is looking pretty good. Let's use G as a free rotate, and that's not a hold, you just have to hit it once. And we'll orbit that around, we'll rotate that around and get this ready to constrain. C for constrain axis to axis. We're getting lots of practice in those axial mates. And this is still free to slide sideways, we see that there. So let's lock it down with a constraint from the face to the face and apply. And if we did go look at this really close, you'd see just the tiniest gap over here. We're talking 0.006 of an inch. That's about the thickness of a sheet of paper. So not significant in this project. So I'm pretty happy with this. The actual orientation that I plan to use it might look something more like this. And its reach is really just a function of the length of the base. If you're really looking to do an amazing job with this project, you could actually determine, using Inventor, you could determine for yourself if the lamp will fall over when outstretched. The way you would do it is you would have to set all your material properties, and once you did, you could come up here to let's see, is it under inspect? I think it's over, we're looking for center of gravity. It might be analyze or something of that sort. Let's take a quick look through. Inspect, tools. Center of gravity is in here. I don't recall exactly, oh, there it is. It's under the View tab. View, center of gravity. It's out of date. Would we like to update? Sure. Okay, so it says the center of gravity is here. And you'll notice that's out in front of the base, which ends right here. So in this configuration, the lamp will actually tip over, which is not a good thing. However, you have to keep in mind we have not set our material properties. Okay, you do have some mass back here in this aluminum block, and that's also a reason to keep your link arms lightweight. Our 3D print, that's going to be fairly light, but the USB cord does have some weight to it. The LED module has a very small amount of weight. The 3D print is all honeycomb inside, so it's pretty light. Your lathe part, though, does have some mass, so you'll have to set your mass properties to be accurate about that. But if everything were the same uniform material, that's a strange pose for our lamp. That's just because of our degrees of freedom. If we put it more reasonable like this, you can see that the center of gravity is well inside our footprint, so it's not likely to tip over. Now, some of you might be asking, well, what about the welding project? Where do the welded parts come into this? You know, I was wondering the same thing. After I took out the center of this with my truss pattern, I realized I don't have a good way to join the left and right sides. There's not a lot of material left. So what we might try is, this is 0.2 wide. So what I'm thinking is to actually make some plates that fit in to join the left and right sides, and we can get an idea of how that would look. Let's try modeling one. I know the width between those plates is 1.2. So I'm going to start, let's start on the front. I'm going to start with a corner rectangle that is 1.2. And I'll bring this out a little bit more, maybe 0.75. And what we're about to do is going to really bring back your memory from the mini sumo robot design project, in which we did these tabs and slots construction. So I'm sketching back on it. I'll bring out a couple of, you know what, let's make that one rectangle. I think this will work out. I'd like to make the midpoint of that horizontal with the midpoint of my existing geometry. And let's put a very small, a 60 thou. That's the thickness of the piece it'll be mating into. Let's put a 60 thou dimension on that. And let's make this, let's say it's 1/2 inch long. And I don't recall, did I set a width on this whole part? 3/4. Okay, so we can extrude that back in positive space, so we have a tab on there. I want one on the other side. Let's make a mid-plane between two planes, between here and, be careful about where you're picking, here. And let's mirror that feature across that plane and say OK. Now for aesthetic and for weight, let's do a little something. Whoops, wrong plane. Let's do a little something extra to this. Let's maybe project all this. Let's put an offset from out here. Ooh, that's interesting. If we go 0.2, we get something like this. Let's go with that. That's not bad. Not what I was originally envisioning, but we'll keep it simple for this project. So I'm going to save this as my, let's call it lamp crossbar or something of that sort. Again, I'm going to go V1. I may change this later. So in our assembly, I realize I haven't saved it yet. We've done quite a bit of work. Let's celebrate with a save. Lamp assembly. This is my V1. Make sure you know what folder you're saving to. Most of the time it is fine to save all the dependents with the defaults there. Looking pretty good. Let's bring in, we'll tile our windows. Let's bring in our crossbar. So I'd like this guy to live just right up in here. And maybe we do a few of them, and maybe it lives in a few places. And I'm thinking I should constrain this in. C for constrain. Let's orbit around. Let's pick that face there. That's sort of what I want. But we need to find a good spot for it. So something like this, maybe 2 of them, maybe 4 of them if we really want to go all out on it. I am thinking the angle between the 2 faces as a directed angle should be 0 from here to here. And we'll apply that. So that's looking pretty good. I still don't have a perfect location on this. Let's sink it in from the edge. So if we were flush, we'd be at a 0 offset. Let's push it back. The laser is very precise, but let's push it back. Oops, that'll have to be a negative to get our direction. Negative 0.1 is a little far. If we wanted it perfectly in the center, we'd have to think about the math. We were 0.2 on the width of these arms. We're 0.06 on the thickness of this, so that's a difference of 140. So that'll be 70 thou on either side. And we'll apply that. So something like this looks okay. Now I just need to position it this way. Let's put in a constraint from somewhere. We don't have a lot of good hard edges to constrain to. So what if we brought it from here to maybe tangent to here? That seems pretty reasonable. We could put a little offset to knock it downhill if we'd like. And apply. The biggest thing, especially if you're planning to do adaptive modeling, is to make sure that your assemblies are fully and properly constrained. So let's bring in let's see, one more of those guys. So we'll copy paste that. Oh, there it is. Let's do the same thing. So lightning round now. We'll get the face of this guy, constrain to this guy. Looks good. We'll do a flush from the edge out here to the back right here at an offset of 0.07. I forgot to hit that as a negative. Let's find that mate and switch it to a minus 0.07. Typing on the keyboard. Looking better now. Let's position this one. And I might just go off of, let's see, where did I go off of on the other one? We went tangent to that with an offset of 0.1. So let's try it. See? This surface tangent to that fillet with an offset of 0.1 and apply it. So that's looking pretty alright. There's no hard corners anywhere in this design, and the more I see it, the more I don't like it. So let's do something about that. I'd like to get in there, back to our crossbar. I could change that to just a rounded rectangle. In fact, I think I will. I was going to fillet it, but this sort of shape, it follows the tabs, but you don't really see the tabs when it's assembled. So I'm thinking we'll just sketch on here. I'll project it. I'll bring back a rectangle as a 2-point. I'll extrude to fill these regions back in. And I'll come in and just put in 4 fillets in there. I'll turn out that work plane while I'm looking here. We don't need to see it. Let's bring those fillets in. Whoops. Deselect. Oh dear. Now we've done it. Let's try that again. 1, 2, zoom it, 3 through the back, and 4 through the back. And apply it. Let's look back to our assembly and hit our lightning bolt to update. That just looks a little nicer. It still looks kind of chunky. We might want to bring it out a little bit for appearance. So that was back up here where we did that. Oops, let's see, was it here? No, we need to go back into extrusion 3 on this one where we did that 0.2 offset. Let's make it 0.15. Gonna open this up a little bit, make it look a little more sleek. You could certainly do something a little more fancy with the design, but I'm liking how it's looking. Alright, last step. We need to just get that rectangle brought in to this part. So we'll adaptively model it. I need to close my link arm. I need to double click it in my assembly. So again, everything is constrained. Everything is locked down. Let's sketch on it. Let's project geometry. And you'll have to hover over to get them. You'll have to get them one at a time, unless you model it where it's sticking through a little bit. You can cheat it sometimes by bringing it a thousandth or a couple thousandths through, but I had no trouble hovering over to get them. And we can extrude cut that out. What I'm thinking though is, for ease of assembly, the laser is so precise, I'm a little worried about the parts fitting together. So I'd recommend we do an offset on there of 5 thou, and we brought it out 5 thousandths of an inch bigger just to be sure that it's going to fit. If it's a little loose, that's not a problem. We're going to be welding over it, TIG welding over it. So let's do an offset of 5 thou on that projected loop. And now we can extrude cut them out. I'd grab the inside first and the outside, or either way, outside and inside. Make sure you get the whole thing. Cut it through all. Looks good. Important to note, this extrusion we just made belongs to this part. It is possible to make sketches and extrusions in the assembly. Strongly, strongly not recommended, because they don't make their way back down to the parts. They won't show up in the DXFs we export. So with that, you can see, since we're using the same link arm in 4 places, those slots we just made carry through in all the places, and it all fits. We have that 5 thou gap just for allowance for our manufacturing tolerance, and we'll go weld that in with our TIG welder after we produce this. Now that we've boxed this in with those, if we added a couple more to the other side, it'd be much stronger. It'd be a real box. So I might recommend it, but we've taken very thin, very lightweight material and we have made it stronger with other pieces joining in, welded in into a box or a channel. Some of you were asking about bending the metal, sheet metal bending. That's a little out of the scope of what we're looking for and what we'll cover with the time we have, but I'd be happy to show you how if it strikes your interest. We would add a couple more of these up in here. Okay, so we would actually go to laser cut 4. But we're at 1 hour on the video, so just 2 more points I wanted to mention before we wrap things up. You do want to make sure whatever the outer radius of your link arm is, that it's not running into your lampshade. You want to keep that separation there so that that can pivot. On mine, aesthetically, I'm not super duper happy with how the link arms come up above the 3D print, but it is what it is. I could go back and shrink those a little bit down to this height if I'd like, which I may do. With the lathe project, things are looking good in there. That's about what we were going for. We'll have a couple bolts, one coming from each side in here. Don't need to model them. You can put some if you want. Down in the bottom, we'll have one long bolt going all the way through and a wing nut or something of that sort on the side. We'll have a couple button head bolts up from the bottom. You also want to make sure that the design of your link arm clears where your mill block is, that it's not reaching down so far that it can't pivot down here. But overall, this is our desk lamp. So sheet metal sculpture's got the base, the link arms. You could do 2 different designs if you have time, but 4 copies of one design should work great. We've got the crossbars we just put in. We've got our mill project, our lathe project, and our 3D print project, and hopefully a little bit of welding with our crossbars once we have them made. And this is a great looking lamp. So thanks for sticking with it through the longest video to date yet for Clark Magnet Engineering. We hope you've learned something, and feel free to reach out to us with any questions you have, and keep an eye out for our next video.